Section 3.3 talks about something called piecewise functions, and we'll use these with most of the functions that we deal with. All it means is that a function is defined in pieces. So for example, we could have a function that looks like this, and it's a parabola, but only for x less than -2, and then it's a to the 5th power polynomial between -2 and 1, and then it's an exponential for bigger than or equal to 1, and we'll talk about exponentials later. But for the most part, the biggest thing is piecewise functions are in pieces. So if we want to find a particular value, for example, if we want to know what the function's value is at 0, we have to look at the piece that contains 0. So this is the piece that contains 0, so we plug it in there. We have 3 times 0 to the 5th, which is just 0. Or if we want f at -3, then we have to use the piece that uses -3, and that's that top piece, and plug that in, and we get -4. And if we want our function value at 2, we're looking at this bottom piece, so that means it's 4 squared, which is 16. Now, if we want to graph a piecewise function, let's say we have x plus 1 for x less than 0 and -x for x greater than or equal to 0. Well, what we do is we find this one here. So its y-intercept is at 1, and we want to only draw the line for x less than 0, so that's over here in the second and third quadrants. So in order to do that, we find another point, and we can go down and to the left because it's a positive slope. 1 over 1 down and to the left makes it positive, and we draw our piece. And then for this one, we've got -x. Now, we need to pay attention here because I messed that up. When you have a less than sign, remember, that means it's not equal to there, so you're going to put a hole. If you have x greater than or equal to 0, then it's equal to 0 there, and then our next point, it's a negative slope, and there's our function. So it's in pieces. You just have to graph the pieces on their particular intervals that you're given. There's a couple of piecewise functions that you need to know about. There's the greatest integer function, and it looks like this. F of x is equal to, and it's either brackets like that or it's written int x, and this is a function. It's doing something specific. These brackets means it does something specific. And the domain of a greatest integer function is all real numbers, but the range is only integers. And what it means is each function value is the greatest integer that's less than or equal to the x value. So if you graph that, for example, 0 is 0 because 0 is the greatest integer less than or equal to the x value. But then like at 1/2, well, the greatest integer that's less than or equal to the x value is 0. So it's going to go along here. All these fractions, the greatest integer that is less than or equal to them is 0. Then when we get to 1, we'll put a hole there because it's not at there. The greatest integer that's less than or equal to 1 is 1. And then all those fractions, the greatest integer less than or equal to them is 1. And then at 2, the greatest integer less than or equal to 2 is 2. And then all the fractions, 2 and some, the greatest integer less than or equal to is 2, and so forth. So the greatest integer function is the function value is the greatest integer that's less than or equal to the x value given. And it looks like this. It's a step of horizontal lines. It's a piecewise function given by horizontal lines. Now another piecewise function is an absolute value function. So for example, you could have the function is the absolute value of x. Now a way to define that is in pieces. It's just the line y equals x for x greater than or equal to 0, and it's the line y equals negative x for x less than 0. Remember, an absolute value function, hopefully you've seen this before, should have, looks like a V, because we took this part of the line here that would have been going down here and flipped it up, because it's an absolute value, so everything has to be positive. Now, we need to talk about shifts and translations. You have a vertical shift, C units up if you have your function value plus C, and C units down if you have your function value minus C. And then you have a horizontal shift if you go C units to the right if your input changes to x minus C, and C units to the left if your input changes to x plus C. Notice for the horizontal, it looks, with the signs, it looks opposite of what you would think. And then you have a reflection in the x-axis, so it flips over the x-axis if you change the sign of the function. So how does that help? Well, if you know what certain things look like, you can just translate them. So if we have f of x equals negative the absolute value of x plus 3 minus 3, well, if we take our g of x, then we know what it looks like. I don't have enough room over there. If we know what the plain old absolute value of x looks like, let's put it over here. We know it looks like this v. So this is g of x. Then what this tells us is that we're going to flip it over the x-axis, and we're going to go left 3 units and down 3 units. So we're going to take our vertex, because that's the easiest point to start with, and we go left 3 units, down 3 units. So here's our new place for our vertex, and it's going to flip over, but it should be the same width out, and you have your new function f of x graphed without really having to think about it too much. Now, a greatest integer function, you can also do that. Let's say we have f of x is the greatest integer of x minus 1 plus 3. And we know what the greatest integer function looks like. We know that it starts like this. I'm just drawing sketches. Of course, it keeps going in both directions. Excuse me, on and on and on. So if we want to do this one, we're going to go up 3 and to the right 1. So we go to the right 1 and up 1, 2, 3, and we're here. Go to the right 1, up 1, 2, 3, and so on. And like if we kept going over here, our g of x would be here. So all these pieces to the right 1, up 1, 2, 3, it just shifts the whole graph, right 1 and up 3. Make sure you know about those, how to deal with those translations. Let's say I ask you to use those translations to write a function. So a step function is a greatest integer function. Let's say we want to have a step function that's moved 2 units up and translated 3 units to the right. Well, what does that mean? That means we're going to have a greatest integer function because it's a step function. 3 units to the right means our input is going to be x minus 3 instead of just x. And then instead of having nothing off to the side, since we went 2 up, we're going to go up 2. Make sure you've read section 3.3, looked at the greatest integer function and the absolute value functions thoroughly, and understand what a piecewise function is and how to translate graphs from the basic ones that we know. Make sure you have some questions written down for class as well.